Okay. By the time, so this is quadratic formula. By the time we are finished with today, you will have gone through solving using factoring, solving using square roots, and then solving using the quadratic formula. Again, quadratic formula is the only one that can be used on any of them. If there's an x squared and an x, we cannot use square roots. And if it's prime, we cannot factor. So there's going to be times in which you would be forced into quadratic formula, but it is something that you could always use. Obviously, square rooting both sides is faster than using the quadratic formula, and factoring is faster if you know what you're doing. But there's going to be times in which you have to use the quadratic formula, which is if it is used on a times x squared plus bx plus c equals 0. So the a is what's in front of the x squared, the b is what's in front of the x, and the c is the constant that is all by itself. If there's a negative in front of any one of those, you keep it with the sign. So if it was minus 3 at the end, then my c is negative 3. The quadratic formula is negative b plus and minus the square root of b squared minus 4ac all over 2a. That is something you are going to memorize. You are going to use it for every math from here on out. So you'll see this again in Algebra 2. You'll see it again in pre-calc. Like, quadratic formula does not go away. And standardized tests love it, okay? The goal is to just plug in your values, simplify as much as you can, and then at the end you'll end up with 2 answers. Sometimes it's a plus and a minus, and sometimes it's 2 completely separate answers. So this would this could literally just say solve, or it could say solve using the quadratic formula. If it just said solve and you tried to factor for number 1, you would find that there's no factors of positive 2 that sum to negative 4. So you would have to use the quadratic formula. So for this one, my A is 1, my B is negative 4, and my C is 2. And then I plug it in, negative B plus and minus the square root of B squared minus 4AC all over 2 times A. Negative 4 would become a positive 4 plus and minus the square root of negative 4 squared minus 4 times A, which is 1, times C, which is 2, all over 2 times A, which is 1.
How many of these quizzes are going to be on the test?
There's not even made a test yet. There's a quiz in 2 days.
How many questions?
I don't know it off the top of my head. I didn't count.
So, are we getting
No. No. So it's 4 plus and minus the square root of negative 4 squared is 16 minus 4 times 1 times 2, which is 8, over 2, which is 4 plus and minus the square root of 8 over 2. Now, if at this point the square root is a perfect square, I would square root it, and I would keep going, and I'd have 2 answers at the end that are simplified into 1 digit. For this, I have to see if it's not a perfect square, which it's not. Can I simplify it? 8 would be 2 and 4, or 2 and 2, and then 1, 2 comes out to the front. I'd get 4 plus and minus 2 root 2 over 2. And then only if the same number goes into all 3 of those spots can I reduce it. If it was 4 plus and minus root 2 over 2, it would stay that way. But because that 2 in the denominator goes into both the 4 and the 2, I would reduce this, and it would be 2 plus and minus square root 2. You can leave it plus or minus. If it wanted it separated, it would be 2 minus root 2 and 2 plus root 2. Correct. It has to go into both. Otherwise, you can't. All 3 of those spots have to be reduced by the same number. Yep. Sure. Question so far? Yeah. Okay. All right. That's it. It's basically that on repeat. Different kinds of answers. So 2, my A would be 1. My B is negative 3. My C is negative 2. I get negative 3, so it's 3, plus and minus the square root of negative 3 squared minus 4 times A, which is 1, times C, which is 2, all over 2 times A. Negative 2, thank you. 3 plus and minus the square root of 9. Negative 4 times 1 would be negative 4, times negative 2 is a positive 8. So 9 plus 8 over 2. And I'd get 3 plus and minus the square root of 17 over 2.
So therefore you just leave it like that?
Correct. 17 doesn't break down. 3 can't go into, or 2 can't go into the 3 and also into the 1 next to it. So it literally would stay like this. If it wanted it spread out into 2, then I would rewrite it as 3 minus square root 17 over 2 and 3 plus square root 17 over 2. But if this is like a quiz answer and it's open-ended, you could totally leave it as plus or minus. All right, go to 3. What's A?
Negative 2.
Nope. 1. B.
Look at the first step.
2. C.
Negative 8, 48.
Negative 48. So negative B plus and minus the square root of B squared minus 4 times A times C all over 2 times A. Negative 2 plus and minus the square root of 2 squared is 4. 4 times 48 is 192. They're both negative, so it's positive 192 over 2. Negative 2 plus and minus the square root of 196 over 2.
Pretty sure that's a perfect square.
Is it?
196. 50, 60, one of those.
2, if we don't know, right? 2 and it would be 90.
2.
No,
Wait, no, it's
98.
4, 10.
2 and 98. 2 and 49. 7 and 7. So a pair of 2s comes outside and a pair of 7s comes outside. So it's 14. So I get negative 2 plus and minus 14 over 2.
Now we can simplify that.
And then you got to keep going. Yeah, so if there's no root left in that answer, you keep going. This would become negative 2 minus 14 over 2 and negative 2 plus 14 over 2.
Where does it simplify it?
It's going to. You don't need to simplify it first. You could wait till you combine it and then simplify it. Or you could do that here. You could do that and then do 1 plus 7 and 1 minus 7. It doesn't matter how you do it. It's just, they won't all necessarily simplify by way of dividing the same number into it. But if there is a perfect square, they will all simplify into at least one term. So this would be negative 16 over 2, which is negative 8. And this would be positive 12 over 2, which is 6. So something that would result in 2 numbers without square roots, so 2 rational numbers, would have been able to have been factored. If you look back at the original question and you will ask yourself, are there factors of negative 48 that sum to 2? The answer is yes, and that would be negative 6 and positive 8 when you factored it, but then when you set it equal to 0, they change signs. Mars.
I think this is easier than first time class, so I can just do this for everything.
So this you wouldn't have needed to do first times last, right?
No, you didn't.
You would have just looked for the factors of 48 and find, and that sum to 2. But yes, you can do quadratic on anything. Questions on any of those? Jonathan,
Zoom in on the page on the bottom.
which one, 3? All right, so what's A for 4?
A is 3.
What's B?
B is
11. C is
6.
6. So it's negative B plus and minus the square root of B squared minus 4 times A times C all over 2 times A. I'd get negative 11 plus and minus the square root of 121. This is 12 times 6 is 72. So minus 72.
Why is it minus 7?
Because it's 4 minus 4 AC is the equation. Over 6. 121 minus 72. Square root of positive 49. over 6. Square root of 49 is 7. So this is an example, like I wouldn't obviously be able to simplify this like we talked about before, but I can split it, simplify it, meaning like reduce it all by the same number, but I can keep going. Negative 11 minus 7 over 6, negative 11 plus 7 over 6, negative 18 over 6, which is negative 3, and negative 4 over 6, which will reduce to negative 2/3. So you want to make sure you reduce any fraction you get. Raise your hand if you got it right. Okay, so that is an example of one, because there are rational answers at the end, that would have been able to be factored, but you would have had to do first times last. Questions on that one? All right, go to 5. A is 1, B is 14, C is 36. Negative B plus and minus the square root of B squared minus 4 times A times C, all over 2 times A. Negative 14 plus and minus, what's 14 squared? 196, good, what you said. 196 minus 36 times 4, 144, over 2. Negative 14 plus and minus the square root of 52 over 2. And then 52 is 2 and 26, which is 2 and 13. 2 2's comes to the front as 1 2. And I get negative 14 plus and minus 2 square root 13 over 2. And because 14 and 2 are all divisible by the same number, I would simplify that, and I'd get negative 7 plus and minus square root 13. Questions?